Find the polarization produced in a dielectric material, okay, dielectric material. Of the relative permittivity is 15. Presence of an electric field of, okay, how much? 500 volt per meter. Okay, so we have the polarization equation F0 F1 r minus 1 into E. So substitute the value 8.85 into 10 to the power of minus 12. F1 r is 15 minus 1, E is a 500 is there. Then substitute all values, we will simplify that. 6.198 into 10 to the power of minus 8 centimeter square. This is the polarization of produced by the medium. Okay, next, the dielectric constant of the sulfur is, okay, 3.4. Assuming a cubic lattice for the structure, now calculate the electronic polarization of sulfur. Okay, given that the charge of the sulfur is equal to 0.07 grams per cubic and atomic weight is equal to 32.07. this is there. Right, given values all constant sign, charge of density 2.7, this is a gram, then you multiply this in kg in 10 to the power of 3. Okay, then atomic weight is 27. So right, according to that, so we have the relation. Okay, we know that, right, directly we know that F1 r minus 1 divided by F1 r plus 2, this value is equal to n of F1 E divided by, okay, 3 times of F0. This is the standard value we have. Alpha E is equal to, alpha is keep is as it is, equal to what we write. Okay, what will write? So the 3 will go, come out, 3 F0 will go up, okay, divided by, okay, n will come down into F1 r by minus 1 by F1 r plus 2, this value, so called as equation number 1. But the number of atoms, okay, atoms per unit volume is given by a relation, that is Avogadro numbers into 10 to the power of 3 into its density divided by atomic weight. So then Avogadro number is 6.025 into 10 to the power of 26 into 10 to the power of 26 into 2 what is that, 07 is given, no? 2.07, okay, into 10 to the power of 3, okay, into 10 to the power 3 divided by atomic weight is 32.07. okay, substitute and simplify all this value, then we will get the number is equal to, n is equal to how much, 3.89 into 10 to the power of 28, it will be there, 28. Therefore now substitute the electronic polarization, okay, by in the equation, right, that is, okay, what is the formula? 3 F0 is equal to 8.85 into 10 to the power of 12 is there, divided by, okay, what is the n value got, 3.89 into 10 to the power of minus plus 28 into F1 is 3.4 minus 1, F1 3.4 plus 2. So this you simplify, means you will get alpha E is equal to 3035, okay, into 10 to the power of minus 14, okay, Fermi per meter square. This is the electronic polarization, okay, polarization. Write another one, okay, here only, okay. Now wait, now an elemental, okay, solid dielectric material has a polarizability is 7 into 10 to the power of 14, polarizability P is equal to given, okay. Assuming that internal field of the Lorentz field, okay, calculate the dielectric constant of the material if the material has 3 into 10 to the power of 28 atoms per meter has. Already you know polarization is given and the number of atoms is given, 10 to the power of 28 is given. So according to internal field, we can determine the internal field is a Lorentz field. So therefore we know the relation F1 r plus 2, we know the n into 3 of F1 is there. So take one side all, okay, here n value is there, okay, this is n value. So electronically polarization is what, P is value is there, 7 is there, divided by 3 into constant value will substitute. So this will be 0905. Substitute all these two values here, you will get this. This is called the F1 r minus 1 by F1 r plus 2. Again F1 r minus 1 can be written as it is, that is, okay, 7906 into type of epsilon r plus of 2, wait, epsilon r plus 2. So simplify this, okay, simplify this, you will get this into epsilon r, point this into epsilon r, okay, plus into plus minus plus, okay, this 1 into 0.7 epsilon r plus 2 is this into epsilon r, and 2 into this, okay, 2 into this, how much it is, calculator lada, 2 into epsilon r, how much, 0.07906 is equal to 1.5, this is 1.506. so adding these two, okay, adding these two, we will get that, okay, we will get that epsilon r 1 minus, okay, the value 0.7 is equal to 2.5812, and epsilon r is equal to, okay, epsilon r is equal to, so right, 2.519 minus of divided by 2, this is equal to 12.33. only simplification is there, substituting the values and simplification there. So this will be 12.33 is a dielectric constant for a given material, okay, stop it.